Okay, so this is a circuits question that asks what is the current through the 8 ohm resistor. You can't quite see the circuit diagram, so I'm just going to draw it out here. So we've got 24 volts running this way and this way, and see if I can do this without it. Alright, and so this is the 8 ohm resistor. This is 4 ohms, 6 ohms, 12 ohms, and 2 ohms. Okay, so the the 8 ohm resistor that it's referring to would be this one. So we're looking for the current through this resistor. To start us off now, we need to know what current is running through the circuit, and we need to know what our equivalent resistances are to do that. So we're going to start off with this first parallel set of resistors here and say that 1 over R is 1 over R1 plus 1 over R2, which can be continued indefinitely no matter how many resistors are in parallel, but there's just 2 of them. So 1 over 6 ohms plus 1 over 12 ohms, giving it identical denominators, so 2 over 12 ohms plus 1 over 12 ohms, which equals 3 over 12 ohms. 3 goes into 12, so 1 over R is equal to 1 over 4 ohms, or R equals 4 ohms. So we can redraw our circuit now like this. And these are getting increasingly bad, but okay. So that's 4 ohms, that's 4 ohms, and that's 2 ohms. So this is our equivalent circuit. Now resistances in series, you just sum the resistance, so that's really an 8 ohm resistor. Meaning that these two together, these two are both identical paths. But if we're looking for our total current, and I'm just going to do this fully, we could take a shortcut here, but for now I'm just going to do it fully. So we want to get this equivalent resistance now. So we want to get the equivalent resistance for this whole thing. So again, 1 over R will be 1 over 8 ohms plus 1 over 8 ohms, which is 2 over 8 ohms. And 2 goes into 8, so 1 over R is equal to 4 ohms. 1 over 4 ohms, so R is equal to 4 ohms. Okay, so the resistance for that path is 4 ohms. So again, redrawing our circuit. And I guess I should have a 24 volt there. So redrawing our circuit, it looks like this. And now we have a very simple circuit which we can readily use in Ohm's law. So V equals I R. So I equals V over R, which equals 24 volts. Our total resistance for our circuit is 6 ohms. So 6 ohms. So 6 goes into 24 4 times, so our current is 4 amps. So that's our total current. That's not our current through the 8 ohm resistor, that's just our total. So now returning to our circuit diagram, our original circuit diagram, okay. So our 4 amp our 4 amp current will be maintained up to this point, after which it splits. Again, I'm just going to we could take a bit of a shortcut here, but I'm just going to do it out fully, just to show how this would be done in any general question. So we need our potential here. So we need to know what the potential drop is across the 2 ohm resistor. So the current is 4 amps. So then the potential drop will be 4 amps times 2 ohms, which is 8 volts. So that means that the potential at this point is 16 volts, which is just 24 volts minus 8 volts. The voltage in parallel paths will always be the same, so that means that this is 16 volts. And the complete voltage drops across the whole thing, so this will be 0 down here. So that means that the current through our 8 ohm resistor is I equals V over R, which is 16 volts over 8 ohms, which is equal to 2 amps. Now the shortcut we could have taken here is by remembering that both of these paths are 8 ohms, and so that means that the current will be split exactly in 2. Since the current's 4 amp, then we would expect that the current in one of the branches would just be half of it, so 2 amps. But it's not always going to be that way, and so it's better to just see how it's done. Okay, so now if we look at the solution here, here is the circuit. They've correctly calculated. Okay, that was great. Thank you for that. They've correctly calculated that the equivalent resistance in there is 4 ohms, and so then that piece there is 8 ohms. At this point, they attempted to take a shortcut by noting that the current, because these 2 legs are both 8 ohms, and that's the only place where the current's going to split, then that would mean that the current through those legs is just half the total current, and the total current will go through the 2 ohm resistor, and then through these guys will just be half of the current. Or put another way, the current through the 8 ohm resistor, taking the current through the 8 ohm resistor, the current through the 2 ohm will be double it. So what that would mean is that, so the shortcut that they attempted to do was to say that 24 volts is equal to 2 ohms times so 2 ohms for the 2 ohm resistor, and it should have been multiplied by not I2 over 2, but actually 2 I2, and then plus that would be 8 ohms for the 8 ohm resistor, which is this one over here, times I2. And so then if you do this out, then that would be 4 plus 8 is 12, so 24 volts is equal to 12 I2, or I2 equals 2 amps. So again, right from here, we could have taken this kind of a shortcut, but as you can see, it's possible to make an error in your logic and therefore get the wrong value out. Mistake in last equation, giving the wrong value for current 8 ohm resistor. Okay. Okay, so that's how you do it. And I would recommend just doing it fully, especially on a test, so you don't make these kinds of mistakes.